Alright, so kule video le ngifuna check ama examples of acids and base. So sesiningile ama definition ukuthi an acid can be defined in terms of Arrhenius theory, and number 2 we can define an acid according to Bronsted-Lowry. Or same thing applies to a base. You can define a base according to Arrhenius, and you can define a base according to Bronsted-Lowry. So now ngifuna sinikeze ama-examples of acids bese sinikeze nama-examples of ama-base, right? So the most common acids, we have hydrochloric acid, which is HCl. Okay, hydrochloric acid. And number 2 we have sulfuric acid, H2SO4. And then number 3, nitric acid, HNO3, or nitric acid, right? And then maybe number 4, hydrobromic acid, which is HBr. Hydrobromic acid. And okay, number 5 we have carbonic acid, okay. Number 6, let's end with acetic acid, which is CH3COOH, right? So you don't have to cram them. Akumelanga wacram wonke ukuthi okay we have maybe 6 examples, no, but then kumele wazi ukuthi H2SO4 it's sulfuric acid, right? HNO3 it's nitric acid, kanjalo kanjalo. Okay, so also have some examples of a base. Okay, so number 1 we have potassium hydroxide, potassium hydroxide. Okay, and then we have sodium hydroxide, right? Number 3, lithium hydroxide, okay, and then ammonia NH3, it's also a base. So these are some examples of a base, and these are examples of acids. So these acids and base, they can be classified into 2 groups, such as, okay, asiqale classify lama acid. So if we have an acid, we can have a strong acid, and we can also have a weak acid, right? So same thing applies to our base, we can have a strong base, and we can also have a weak base. So define lama terms lawa, and then sneeze lama examples, right? So what is a strong acid? Siyazi ukuthi an acid ionizes in water, right, to produce hydronium ions. But if ukhuluma nge strong acid, this is an acid, acid that it ionizes completely in water. So it is an acid that ionizes completely in water, right? To produce, we do know that acid produces some hydronium ions, né? But if it's a strong acid, it produces a high concentration of hydronium ions. So ihluka ngani the definition from the actual definition of an acid according to Arrhenius. According to Arrhenius, an acid is a substance that ionizes in order to produce hydronium ions, right? But what if it's a strong acid? We say it is an acid because we already know that it's an acid. So we say an acid that it ionizes completely. So this is the key term. It ionizes completely in water to produce a high concentration of hydronium ions, right? So that is a strong acid. And examples of strong acid, we have examples as one now we have hydrochloric acid, a strong acid, sulfuric acid, a strong acid, hydrogen bromide, which is hydrobromic acid, a strong acid, right? Okay, and these are only 3 examples. We have sulfuric acid, strong acid, hydrogen chloride, a strong acid, HBr is a strong acid, and then etc. Right? Okay, so what about a weak acid? So we do know that a strong acid, it ionizes completely. So what about a weak acid? So it should be the opposite of a strong acid, right? So this is an acid that ionizes incompletely in water to produce. So instead of a high concentration, it produces a low concentration of hydronium ions. All right, so the key terms in this definition is that it is an acid that ionizes incompletely. So it ionizes partially in water to produce a low concentration of hydronium ions. So that is a weak acid. An example of a weak acid, we have the acetic acid or the ethanoic acid. Right, so ethanoic acid, which is the acetic acid, which is CH3COOH. So that is an example of a weak acid, right? Okay, so let's define a strong base and a weak base. So a strong base it is a base, and a base dissociate in water, right? It is a base that dissociate completely in water to produce a high concentration of hydroxide ions, because a base dissociate and a base produce hydroxide ions, right? So the key terms is that it dissociates completely and produces a high concentration of hydroxide ions, which is the OH minus, right? And then the weak base is the opposite, right? And then the weak base is a base that dissociate incompletely in water to produce a low concentration of hydroxide ions, right? So the key terms is that it dissociate incompletely to produce a low concentration of hydroxide ions. So examples, what are the examples of a strong base? Potassium hydroxide is a strong base, sodium hydroxide is a strong base, lithium hydroxide is also a strong base, and etc. And then examples of a weak base, we have ammonia. Ammonia is a weak base. Okay, so these are some of the definitions that you have to know. We do know that a base and an acid can be defined using two theories, but they can further be classified as a strong acid, weak base, or a strong base and a weak base. All right, so let us explain these terms using an equation or a chemical reaction, right? Let's start with a strong acid. So for example, if I have a strong acid, an example of a strong acid, we have HCl, right? So in total HCl layer, put it in water, right? So it will donate this hydrogen ion to form, if a hydrogen ion liza ngapha, then it means ngapha zoba 3 manje. Then we have H3O plus, and then if this is no longer there, then kusala uCl minus, right? Because an acid is a proton donor. All right, so let's say sine reaction ekanje. HCl sifake emanzini isinikeza H3O plus Cl minus. Okay, so lama reactions lawa so understand ngcono sense ama reactions akhona, ne? So now if it is a strong acid, we have the fourth reaction, which is actually the ionization reaction of this acid, right? The acid yashinja iba produce lama ions, and then we have the reverse reaction. This is the fourth reaction, and we have the reverse reaction. We have the reverse reaction, which is actually taking these ions back to the acid, right? But then if this is a strong acid, the forward reaction is highly favored compared to the reverse reaction. So for example, lama arrows law, instead of tiswadrowa kanje alingane, sizowadrowa in such a way that the reverse reaction is less favored, right? So that is why it can be able to ionize completely. The forward reaction is highly favored. So kuba ngathi reaction a forward reaction kuphela, we are only ionizing these acids for mama ions, right? But then what if it's a weak acid? What if it's a weak acid? For example, we have that acetic acid CH3COOH sifake emanzini, right? And then to like melibeka so is near the right. An acid is a proton donor, so it's a donator le hydrogen le is near the H3 O plus bese lapho izosala ithi CH3COO lo H awusekho minus, right? So rangisana space la. So now okay, let me just write it like this. We have H3O plus CH3COO minus. Yeah. All right, so since this acetic acid or ethanoic acid, it is a weak acid, right? It means the reverse reaction is highly favored compared to the forward reaction. Sayabo? So the reverse reaction is highly favored compared to the forward reaction. So it will ionize, but it will ionize incompletely, or it will ionize partially. So in terms of a chemical reaction, see, explain the weak acid and a strong acid, whereby the forward reaction is highly favored in a strong acid, and the reverse reaction is highly favored if it is a weak acid, right? And then how do we explain the base? For example, we have potassium hydroxide, which is a strong base, right? And sifake emanzini. So nasifake emanzini, made us today something like or let's say dissociate, right? Dissociate, so it means it will give us potassium plus OH minus, right? So since a base dissociate, and this is a strong base, it means the forward reaction will be highly favored compared to the reverse reaction. But then if it is a weak base, such as ammonia, right? So let's say ammonia, nasifake emanzini. So nasifake emanzini la, should be a reversible reaction. And okay, so in this case, this is a base, then it means lena kuzobe acid. The acid is a donator. Hydrogen Li1 lapha kuzoba nama hydrogen I4, then plus, and then la kuzosala OH minus, right? All right, so since ammonia is a weak base, it means the reverse reaction is highly favored compared to the forward reaction. So this is how we explain a strong base and a weak base, strong acid and a weak acid in terms of an equation.